Let's say a person is running, and her acceleration and velocity are in the same direction. Should she be speeding up or slowing down? The rule says if A and V are in the same direction, she'll be speeding up. So maybe she's moving to the right at 1 meter per second. And we are going to give her a rightward push, a rightward acceleration. So a little bit later, she'll be going faster, maybe at 6 meters per second. Let's say that we've got A and V in the same directions, acceleration and velocity. We expect her to be speeding up, but this time she's going to the left. So her velocity is -3 meters per second. If we give her a push to the left, if she accelerates to the left, then she'll be going faster. 11 meters per second is her speed. So her speed changed from 3 to 11, and when I cite her speed, I take away the negative, because speed can't be negative. Now if we have a person, a runner, who's going and running so that her acceleration and velocity are in opposite directions, we expect her to be slowing down. So let's say she's going to the right, but we're going to push her, we're going to accelerate her in the opposite direction. That'll cause her to slow down from 6 meters per second to 1 meter per second. We could have another scenario where she's slowing down, but this time she's moving to the left. If we push in the opposite direction, right, acceleration is opposite, that will cause her to move at a slower rate, something like 3 meters per second. So her speed has gone from 11 meters per second to 3, but her velocity is still negative in both cases because she's moving to the left. Let's try to use these rules for a question. An eagle is flying west while accelerating to the east. The eagle is A, speeding up, B, slowing down, C, maintaining the same speed, or D, not enough information. To answer the question, we have to figure out whether the acceleration and velocity are in the same direction or opposite directions. So first it says the eagle is flying west. That means the eagle is traveling to the west, or the velocity is negative, because west would be kind of to the left on a map. And then it says the eagle is accelerating to the east. Now that's talking about the acceleration, and east would point to the right on a map. And because of that, because it would point to the right, that's going to be positive. So what's the answer? Well, acceleration and velocity are in opposite directions. And because the two are opposite, the eagle is slowing down. Now we're going to take a time position table. We've worked with this before in our lab, but now we're going to start to answer questions on these. So it says an object's position time data is shown to the left. When the stopwatch shows 0 seconds, the position, the location on the x-axis, is 1 meter. When the stopwatch shows 1 second, the object is located at the position of +2 meters on the x-axis. At 2 seconds, the position is 3. At 3 seconds, the position is 4 meters. And we're asked the question, is the object moving? So think about this and try to answer. The answer is yes, because the position is changing. If the position changes, the object's not staying in the same spot, it's moving. Now let's show a second question. Is the object accelerating? Explain why or why not. Try to answer this question. Pause the video and see if you can answer it. Here's a hint. To answer whether or not the object is accelerating, you want to look at whether the displacements are getting bigger, smaller, or staying the same. Okay. The answer to this question is no, it's not accelerating because the displacements per second aren't changing. From here to here, between 0 and 1 seconds, it moved 1 meter. From 1 to 2 seconds, it moved 1 meter. 2 to 3 means it moved 1. From 2 to 3 seconds means it moved. From 2 to 3 seconds, we look at the data and we see it moved 1 meter again. So those displacement arrows aren't getting bigger, and the displacement arrows aren't getting smaller. That means the object is not accelerating. Now we're given an object's velocity time data. This is no longer position. Now this shows how fast the object is going and in what direction. So at 0 seconds, the velocity is 1. At 2 seconds, the velocity is 1. At 0, it's 1. At 1 second, the velocity is 1. At 2 seconds, the velocity is 1. And at 3 seconds, still 1. Okay. Is the object moving? Try and answer the question. The answer is yes, because the velocity isn't 0. The only way an object is not moving is if it has a velocity of 0. Any other velocity means the object is moving. But is the object accelerating? Explain why or why not. Now, to answer this question, and pause the video, try to answer the question, you have to remember this is velocity, not position. If the object accelerates, the velocity changes. And here the velocity is the same. So there's no delta v that we're adding or subtracting away. We're always getting the same amount, which means the acceleration is 0. There is no acceleration because the velocity isn't changing. If the velocity value went up or went down, in that case we would have acceleration.